is math complex? Is it because there are so many numbers? What about imaginary numbers and complex numbers? Wait a minute. Imaginary numbers? How can I even imagine numbers? Why numbers? Numbers came around when people wanted to count, say, sheep. During the Paleolithic era, people started counting with the help of tally marks. But as life became complex, tally marks were no longer sufficient. That's when we came up with digits to represent numbers. To organize these digits, we put the natural numbers into a sequence called the number line. Back then, there were creative pioneers who started questioning the existence of everything. So now, how do we represent something that does not exist? That's when zero came into the picture. Zero also gave rise to the positional or the decimal system. So, it was not just the value that the number possessed, but also the place where it was written became important. With the growth of civilization came money. With money came debt. People needed ways to keep track of who owed how much money, and to do this, we created negative numbers. Negative numbers were the flip side of numbers, a dark reflection. By then, civilization had grown even bigger. Land was being conquered and divided. Dividing a piece of land would not be possible if not for fractions. Think of it as A divided by B. Every number that could be expressed as A by B was called a rational number only because it was created as a ratio. In A by B, B can be any integer except a 0. Why so? Try dividing 4 apples by nothing. Absurd, right? That's why. The creative spirit of growing math just could not be contained. It burst forth in great minds such as Pythagoras, Euclid, and Musa al-Khwarizmi. Let's take a right-angled triangle. Both these sides are 1. We get the value of the hypotenuse as root 2. Okay, what is its accurate value? Now, if I take this triangle and put it on this number line, now let's zoom in and zoom in further and keep doing this many times, yet I will still not find an end. Irrational, isn't it? Yes, that is why it is called an irrational number. Even though irrational numbers have a place on this number line, there isn't an exact location that can be pointed. As algebra developed, people could start framing and solving equations representing everyday problems. Soon, algebra was able to forge strong bonds with geometry using the Cartesian coordinate system. This curve could be represented algebraically by this equation. And to find out where this curve cuts the x-axis, all that you had to do was to equate y to 0, and the values of x so obtained were called the roots of the equation. This is where things get a little complex. Let's solve this equation and you get the value of x as To solve this, we will have to find a number which when multiplied with itself will give you -1, which in fact is impossible. And this curve does not even cut the x-axis. But then this guy had a leap of thought. He said our missing numbers are not to the left or right of this number line. In fact, it was not even there on this number line. We were required to imagine another dimension. Now, if I get the other dimension in, you see that the curve actually crosses the axis. Instead of writing this as root of -1, Euler gave this number a symbol, I. Because we were supposed to imagine another dimension to see this number, we called it imaginary numbers. Now, all the numbers on this one-dimensional number line are called real numbers, and the numbers that have root of -1 as a factor or I in it are called imaginary numbers. Now, what would happen if you were to mix both these numbers? You would get complex numbers. To understand why we need complex numbers in our simple lives and a lot more, all mapped to your syllabus, download byju's, the learning app.